Hello guys, welcome back to Tough Math, a YouTube channel that features uh, solutions to some math competition problems given in the past several years and given here and abroad. So our problem for today is this. Evaluate S, which is the sum of the greatest integer value of 65k over 107, where k ranges from 1 to 106. Okay, first we note that when x and y are not integers, but x plus y is an integer, then the greatest integer value of x plus the greatest integer value of y equals x plus y minus 1. Example. Our x is 8.53 and y is equal to 3.47. Then x plus y is equal to 12. But the greatest integer value of x plus the greatest integer value of y equals the greatest integer value of 8.53 plus the greatest integer value of 3.47 equals 8 plus 3, which is equal to 11, which we can write as 12 minus 1. So that's it. Moreover, for k equals 1, 2, 3 up to 106, okay, 106, we have 65k over 107 plus 65 times 107 minus k over 107 is equal to 65 over 107, which is common to both, times k plus 107 minus k, which is equal to 65 over 107 times 107. Therefore, this is 65. It follows that the greatest integer value of 65k over 107 plus the greatest integer value of 65 times 107 107 minus k over 107 must be equal to 65 minus 1, which is equal to 64. Okay. Thus, therefore, S, which is equal to the sum of 65k over 107 of the greatest integer value of 65k over 107 from k equals 1 to 106. So we have greatest integer value of 65 times 1 over 107 plus the greatest integer value of 65 times 2 over 107 plus the greatest integer value of 65 times 3 over 107 and so on, plus the greatest integer value of 65 times 105 over 107 plus the greatest integer value of 65 times 106 over, this is the last term, over 107. Okay. And then pairing of those terms whose sum is 65 minus 1, which is equal to 64, we have, okay, we have S equals greatest integer value of 65 times 1 over 107 plus 65 times 106 over 107. Okay, this is the first pair, and then the second pair is 65 times 2 over 107 plus 65 times 105 over 107. This is the second pair. Okay, to emphasize that, I will use this first pair, second pair, plus third pair, and so on. Maybe somewhere here, plus, and so on, plus the last pair. Okay. The next pair is the greatest integer value of 65 times 3 over 107 plus 65 times 104 over 107. And the last pair would be 65 times 53 over 107 plus 65 times 54 over 107. Okay, so each of these quantities inside the red pair of parentheses is equal to 64, and so we have 64 plus 64 plus 64 and so on, plus 64. There are There are 53 of them. 53 terms. Therefore, this is equal to the sum of 64 from 1 to 53, which is simply equal to 53 times 64, which is equal to 392. Okay, so this is our value of S. Yes, that's the value of S. So before we end, I am leaving you this challenge. Evaluate n, which is equal to 1 squared plus 2 squared over 1 times 2 plus 2 squared plus 3 squared over 2 times 3 plus 3 squared plus 4 squared over 3 times 4, and so on until the last term, which is equal to 2023 squared plus 2024 squared all over 2023 times 2024. The solution to this problem will be given in the next video. So, and also I would like you to think about this quotation from Jawaharlal Nehru, who was the first Prime Minister of India. He said, "Success often comes to those who dare and act. It seldom goes to the timid who are afraid of the consequences." So thank you. I hope that you learned something and you enjoyed our discussion. Goodbye for now, and may God bless you all.